Now that we have completing the square as a tool for working with quadratic equations, we can complete the square on the standard form of a quadratic equation to prove the usefulness of the quadratic formula. So our goal for this video is going to be to solve this equation by completing the square and seeing how the solution ends up as the statement of the quadratic formula. So to get started, because we are going to complete the square, let's begin by moving the constant term over to the right-hand side of the equation and rewriting the equation as ax squared plus bx equals negative c. Also, because we want to complete the square, we're going to divide both sides, or divide everything by a. And we're going to have a new equation that says x squared plus b over ax is equal to negative c over a. It's at this point that we look at the linear term in the middle, and that's the term that we are going to divide by 2 and then square in order to complete the square. So x squared plus b over ax. If we divide that term by 2, we get b over 2a, but then we're going to square that entire term as the additive constant at the end of the expression. Now, if we want this equation to maintain its equality, we're going to do the same thing over here, and we're going to add that exact same term. At this point, we can square both of those terms, both of those constant terms at the end of each side, and rewrite each of them as b squared over 4a squared, and then the same thing on the right-hand side, b squared over 4a squared. It's at this point where you're going to start to see some of the pieces of the quadratic formula start to pop up. I'm seeing a b squared, I'm seeing a's in there, I'm starting to see the a's in a denominator. So there's pieces of this starting to show up. But it's when you get to the next step and we actually factor this right-hand side that we're really going to start to see what's going to happen with the quadratic formula. So when I do that, when I factor this side as a perfect square, the perfect square factorization is x plus b over 2a, all of that squared. Now that is equal to that right-hand side that we already had, negative c over a plus b squared over 4a squared. For the sake of simplicity, we're going to multiply on the right-hand side in an effort to simplify this right-hand side a little bit more. And we're going to multiply both the numerator and the denominator of this first fraction by 4a. And the reason that we chose 4a was because we want to make a common denominator so that we can add. So we're going to keep our left-hand side the way it is. And we're going to multiply the right-hand side, so it says negative 4ac over 4a squared plus b squared over 4a squared. Now we can combine that right-hand side, and I'm going to add the numerators, but I'm actually going to switch the order so that the minus sign is not the leading, or the negative sign is not the leading term. And we're going to write it as b squared minus 4ac all over 4a squared. And now we have the discriminant, and you can see the appearance of the discriminant. So now we're getting closer to the quadratic formula based off of just completing the square and a little bit of extra arithmetic. The next key step of this is to use the square root method and take the square root of that side of the equation. So when I do that, I take the square root of x plus b over 2a squared. That's going to leave me with just x plus b over 2a. But because I'm going to take the square root also of this right-hand side, I need to create my two different roots. So there's going to be the positive version of b squared minus 4ac all over 4a squared, the square root of that. And there's also going to be x plus b over 2a equals the opposite of the square root of b squared minus 4ac all over 4a squared. I'm very close to having this solved for x. I can subtract b over 2a from both sides, and I get negative b over 2a plus the square root of b squared minus 4ac over 4a squared. And then the same thing over here, just with a minus sign in between the two terms. And the last step of this to get it to the quadratic formula is to realize that while I cannot take the square root of this numerator, I can certainly take the square root of this denominator. And if I take the square root of 4a squared, that just leaves me with a 2a, which then matches the denominator over there. And then the same thing would happen here. That's what allows us in the quadratic formula to put the two fractions together. So if you remember our work with the quadratic formula, it doesn't have the two fractions separated like this. It has them together. And the reason is because you can take the square root of 4a squared in order to put them together. So our first solution is the first iteration of the quadratic formula with the plus sign and the common denominator of 2a. And our second version is the same thing, just with the minus sign and still a common denominator of 2a. Now, when we write the quadratic formula, we typically write it with the plus minus so that we don't have to write it twice. But that's how we complete the square in order to get to the quadratic formula. We start with this standard form of the quadratic equation right here. We go through the process of completing the square, which is done by the end of this screen right here. After that, we factor, and we do some algebraic manipulations after that to get a common denominator on the right-hand side. We take our square root using the square root method, and we simplify using good algebraic techniques to write these answers as clean as we possibly can. That's not to say that you couldn't use this formula right here with that big ugly square root in it. That's just not the simplest version that we could create for the quadratic formula. The simplest version is what we see at the bottom. So no, the question is not, do you need to be able to reproduce this every time you solve a quadratic equation? Obviously not. The point of proving it once is so that you don't have to ever prove it again, and you could just use the rule. But the idea of the connection between the completing the square and the quadratic formula, that's where the real value lies.